Okay, so welcome back, guys, and here we are. So I'm just gonna show you what we're gonna do now. So what we'll do in this quick lecture or this lecture, we are gonna try and build another controller that we can use as pole vector, and then we're gonna place that pole vector, and then we're gonna place our actual controller here. We're gonna get that up here, and I'm gonna show you two ways of moving those things around. There's certain math ways that you can do that with some vector math, where you basically measure this vector from here, this vector here, and this vector here, and then you subtract those two from each other and add it back onto the root here, and then the middle of that point would be here, and then you do the same thing for these 2 points, and then you multiply it out as much as you want. So you can multiply that with 2 or 3. So your pole vector will always land. That's specific. So that's a specific certain of math that you can do that with. I'm not gonna do that in this lecture because I don't want to do something too complex. I just want to keep it simple because it's about just understanding the scripting. I don't want to involve math. So I'm gonna show you two ways of moving, and one is with a parent constraint, and the other one, which I do a lot because it's sort of like what I see as the lazy ways. And then there's another one that's called using an X form. So that's two different kind of commands that you can use with Maya. But our overall goal is basically what we have left to do is, when I run my current script here, it's really simple. So this course, as has been mentioned before, is not about rigging, so it's not particularly beautiful rigging, it's more about how I structure my scripts. So what we want to do is we want to have one controller here, and then we want to have another controller out here, and this one will be the pole vector. So with that constraint, parent constraint, and then, oh sorry, we don't want a parent constraint, that's silly. We want to select this one and say constraint, pole vector constraint. So you can see it creates that line. So now my elbow is moving, and then I want to select my controller and my pole vector, oh sorry, my IK handle, and say parent constraint, and now I'll move this one around. So that's the last 3 steps we want to do, of 3 or 4 steps that we want to do. So create the 2 controllers, we got one already. Basically do that process again, move them into position in 2 different ways, and then constrain everything up so it works. And then we sort of like call this introduction course done. So let's try and hit save on that. And afterwards, after we've done with this, so I think I'm going to divide these last 4 points maybe into, like, let's see, maybe 2-3 lectures. So the first thing I want to do now is just create the pole vector. So first of all, we have a controller here, so let's try and pseudocode this. Create pole v control. So we're just going to pass that in here. In this case, I'm going to call this, the name of this one, I'm going to call that the pole control. So we sort of like have them divided into 2 different ones, so into 2 different variables. So in this variable, we're gonna hold the pole vector controller, you know, all the info that we get back from this, so what we return down in this function here. And in this case, we're still throwing in the side and the limb, but we want to change the type name. So down here, if you remember that, we created a name. I'm gonna delete that print statement. We created a name, and the name is created by taking the name here, the side, the limb, and the type. So it took this one would fit to this one, and these 2 would fit to this one, and these 2 would fit to this one. So it's basically saying, oh, there's going to be a string here, there's going to be a string here, it's going to be a string here, and then after this parentheses, sorry, percentage sign, we put them in here. So first one fits with the first one, and so on. So what I'll be doing now is I don't want 2 controllers that are called the same, so I'm going to take this stuff here, and I'm going to rename the type, and we're going to call it IK pole v. So right now we have a pole vector and we got a controller, right? And so I hit save now. So down here, I'm gonna delete this. We're not gonna build the pole vector inside our build IK handle. We kind of want to keep those 2 separate. So we have all the controllers created inside my make arm IK. So this is basically my build script, or my bulk script, and this is like all the the functionality of it, basically divided into a few pieces. So I'm just going to delete this line here. So now we got the pole vector control. So the next thing we want to do now is start placing the controllers. Sorry, I just pseudocoded in a little bit here, like what I wanted to do. So as I said, there's two ways of two obvious ways, basically. There's a lot more than two ways, but there's two obvious ways. Two ways to move stuff around. One, parent constraint, and second would be the X form, and we're gonna look into both of them. So I'm just gonna choose an arbitrary one. I think we're just gonna start out by doing I think we're gonna start out by just placing the hand controller. So what I want to return here is also, like, I only gave it the root joint, and I kind of want to also have the root joint returned. So if I go here, sorry, I want to return all the arm joints, because now I kind of like did the work of finding this list. So I want to return that arm joint. So the way I can do that is saying, like, what is the first thing that comes back? It's the IK. What is the second thing that comes back? It's the arm joint. So if I just do it like this, the two things that are gonna get thrown back will be thrown back respectively into the arm joints and the IK joints. So I can do that here by just, I can try and print that for a second for you guys. And if so I kind of want to show you what actually happens here. So if I say print, and then I can say this is the IK, and let me do like this, and then put in that here. So right now you know what that means. That means that I need to put in a percentage sign to tell it, like, what object am I looking for inside this string. So I'm telling it, look for a string. Which string that comes after the percentage sign? Let's look for the IK. So you're printing whatever is thrown back here. If we've done it correctly, we should get back the IK handle. If I duplicate this line and I print, and I say this is the arm joints, then print these arm joints. And let's try, and we don't want to buy it yet. Save, go back into my, let's try and go back on all this stuff. I could just delete them, because as I said, like, you don't want to just delete stuff, but when you start creating nodes, because you can't just select nodes in the viewport. But for now, I'm just gonna I can delete it in here. That should be alright. So let's try and hit here. Okay, so it prints, this is the IK handle and this is the arm joints. So I get a list of my arm joints and I get my IK handle. So everything's perfect. I get returned exactly what I want. So now we can start using this, and we don't really need to print these statements anymore, because we know that what we got back was correct. So now we want to place the controller, and we want to do that. Let's say place add the hand using constraints. So what I'm going to do now is I'm going to create like a temporary constraint. So in this case, I'm going to move something with my constraint. So you know, when I create a, let's say I create a cube, and I select my joint, and I select my cube, and I say constraint, and I say point constraint, for instance, and I say maintain offset. If I say maintain offset, the cube will maintain its current position. If I say maintain offset is off, it's going to snap back to where the joint is. And that's exactly what we want to do. So you can see here in my outliner under my cube, I have my point constraint now. So we want to kill that, and then the cube remains the position. And that's kind of what we want to do with our controller, right? So let's try and do this. So if I say temp con, so temp constraint, and then we say cmds dot point constraint. Point constraint, and we want to constrain, and let's think about this, we want to constrain our IK, or sorry, our controller to our, well, basically our last joint. So let's try not to use the IK, let's try and use the arm JNTS. And we know that the last object in this list is our end joint, right? So we saw that before. The last object that we got returned here was the RMC. So in this, actually, sorry, I just rebuilt the scene and called this RMC instead. It doesn't really matter, it can be arm and RMC. So if you want the last object in the list, some of you might wonder, you don't really want to always type 2, because sometimes you have, if you have a tail, you can have 30 joints, and you always like want to know what the last joint is called. If you want to like get the last object in the list, you can go -1, and it's going to go from the backwards. So that's basically giving me the RMC joint. And I want to take the RMC joint, so I want to take this joint, and I want to select my controller, and I want to point constrain that. So let's try and do this. So I'm saying, and I want to take my CTRL, and I want to MO equals to 0, maintain. So you know what this means, maintain offset, because that's what we did here, maintain offset. So this is basically just that setting that I'm placing here. So all these things that are here, if I change these things, it's basically what I can define, and that's what you call flags. So I'm flagging right now that I wanna have my maintain offset on 0. And you could write the full name maintain offset, and if you don't know these codes, because you probably won't since you're new to Python, or to Mel as well, which because this is basically Mel code inside Python, you have to, as I showed you guys before, if you go point constraint and you double click and then you say command documentation, and you can go directly there, and then you can see like, okay, what's this thing actually called? And I guarantee you, anything you can find in any Windows, and you want to look for a command of it, what you can do is if you do that command inside your viewport, like if I select these two things and I say constraint, you can see, okay, I get my code written here, like what happened. Okay, the offset is 0, 0, 0, the weight is 1, but it doesn't say anything about maintain offset, and that's because some things are just on for standard, and in this case it just looks at the window already and say like, okay, what's on and what's off, and do exactly what's there. And weight is just how much weight there is on the constraint. So if you have more than one constraint, you can weight them between each other. So one would have a value of maybe 0.4 and the other 1.6, and the object would remain 60% to one end and 40% to the other. Doesn't matter right now. But that's how you find out. That's how you sort of like start developing your code. You use a command, and you look in your script editor, like what did it actually throw, and then you can take it down here and look inside the command documentation. What does that mean? So if I do that now, bam, and you can get like examples down here. They're usually quite good for the most codes. If it's some sort of like something that's not really used that often, then probably it can be a little bit tricky, but you can, there's tons of forums. Anyways, I'm gonna continue now. So let's go into the script editor here, the text editor. So right now I created like a point constraint, and I use this tempcon. So you know that when I use a command, it gives me something back, and obviously it's gonna give me the name of the constraint back. So that will be this object. That's what it's gonna throw back, because that's what it's creating, right? So I know that object is stored in here now, and because I want to kill this connection, because right now I just wanted the position, right? And then afterwards I actually want to reverse that. So I'm gonna kill this, and then I'm gonna say commands.delete tempcon. And this is sort of like the cheap, easy way of getting to a position that you want. Some might call it a little bit dirty, but you know, it works, and it's really fast, and there's no bad thing about using it. It uses a very limited amount of code as well. It should be alright. If you store data points in point positions, which we're gonna do in a second, it's gonna be I reckon it's gonna be a little bit faster. But to be honest, it's not something that you would feel in your code. So right now you'll see that if I hit here, you can see I just run my code, and what it did is it actually placed my controller. So brilliant. And the next thing we want to do is do another way of moving an object. So I'm just going to go back here. So you can see it creates my RK arm, and it moves it up here, which is great. And it creates my L arm IK pole vector, so it named it really nicely as well. So the next thing we want to do is move that up here and then translate it maybe a little bit backwards instead. So I just want to make sure if we do this. Yeah, so what I'm going to do is I'm going to show you a couple of ways to do things here. As I told you, that you can do it with vector math, which is way better, or at least like a lot faster, because sometimes your arms won't be straight, so sometimes they'll look like this, and then it's gonna be hard to find the correct position for your pole vector. But if you use math, it's gonna be a lot more precision. But obviously this course is not about math, so I won't go into that. We're gonna do this manually, also to learn a little bit other commands. So if I go backwards here and we just undo all these things, and I'm gonna show you the other way of placing something, and then in the next lecture I'm gonna constrain stuff up. Okay, so here we go. So if I say command start xform and we want to say elbow position, so elbow position, because we want to put our, if this is our control, we want to put a control here and move it backwards. So first I need to get my object to my elbow. So let's say we want to get that position, and we just want the translation of the world space. So wherever this thing is in world space, you can see here. So basically where the cube is now, I want these values. How do I get that? So the problem right now, there's two problems that we're facing. One problem is that if you look at a joint, it actually inherits hierarchies from the previous joint, so we can't actually use that. We can't use the direct, what we call like parent space position, but what we can do is use the world space position. So we need to get the world space position. So we're gonna xform our arm joints, and we want to do it on the second joint, which is our B joint, right? That's our elbow. And we want to query, and query means that we're gonna, xform doesn't know what it's gonna throw back into this variable, but we can tell it by saying querying an object or querying a value. So one thing that you can go into the command documentation and do, and if I say xform and we go into the command documentation, you'll see here in a second that if I scroll down, some of these values have a Q out here, which means that we can query these objects. So you can see like what value are actually gonna get back, a boolean, okay, and I can query it, yes. So some of them would only be commands, other of them will be queryable. So let's try and, so query is basically just telling us what are we interested in throwing back. And right now we're xforming, which means that we want we get three values. So we want the transform x, transform y, and transform z. And those three values we want to store into the elbow position. And we're looking at the second arm joint. And as you know, we start at 0 when we have a list. So this is 0 and 1. So that's the elbow here. And then we're querying, but what we're querying? We're querying the world space equal to 1. So world space, yes. And we want the translate equal to yes. So right now we're querying the world space translations. And the next thing we want to do is start moving something over to that. So if I go in here and I say, actually I want to use like a little bit more code, because then we can like sort of go over like a couple of more commands. So now you know the xform that can store something. You can also set a value with your xform. So if you go down here and you can say xform rotation true, you can set the rotation. So I could do the same thing here if I duplicated this code here and went down here and said commands.xform. I want to say the translation equals to true, and then we can see I think let's try and go in here. So say translate, or maybe it's transform. Let's see, translation. Okay, so it's expecting a linear. So if I say here, and I go equal to, and then I say elbow position. So since I don't need to throw in like these three values, I can just throw in like this, because it already knows that it's a list of objects, and if it's three objects, it knows that the translation is correct, or it's the translation that we want to do. So if I go in here and I say pole, let's see, pole v control, that's the one we want to move. And where do we want to move it? We want to translate it into the elbow position. That's basically what we're doing, right? So here in this case, we're storing the value. We're storing the value, right? So if I, let's go and delete this. here we store the value and pass it. Let's say here we store the value of our elbow and pass it to our pole V control. So in this case I'm throwing back the position, and that's important that you get that. And in this case I don't need to store anything. I'm basically just telling it to move to this position, right? So let's try and just quickly do this, and this works. So now we have like 2 different ways of placing a controller, and let's see if this works. It might throw an error. I haven't done this for ages, so doing stuff perfect like on the fly is not always super easy. Okay, so we were lucky, so that worked perfect. So there's another command that I want to show you guys before we wrap this up. So we're on 21 minutes now. I think I can put it on to 21 minutes or 25 minutes. That should be alright. So there's another command that I want to show you guys, because right now if I just use this one as a pole vector right now, right? If I take this one and say pole vector constraint pole vector, oh sorry, there we go, and then just parent this underneath this controller. You can see it doesn't, it's really confused. So what I want to do is basically just move it out here. But you know what? I think I'm gonna just cut the lecture here, and then I'm gonna show you how to use what we call a set attr command, because I don't want the lecture to be any longer. Anyways, I hope this is making sense for you guys, and watch it again and again, because you know you're not gonna learn Python in one moment. And I know there's a lot of info that I'm passing you, but I hope that it's sort of making sense. And if it's not, then please do let me know, and I'll try and correct it and make it better. So anyways, yeah, I'll see you in the next lecture, and good luck, and please do let me know if there's anything you need. Okay, cheers guys.